I can't believe we've actually even made it this far, but I'm thrilled that they let us come back and do this for the second time. Even with the wardrobe malfunctions, I figure that by this time here around, we're going to get things perfect. I'm excited for this one, Adam. We get to talk about something that you and I have been dealing with for a very, very long time. We finally get to do a domestic hot water episode.
Yeah, absolutely. It's exciting times. We get to talk about some of the technical side, some about what's going on in the industry when it comes to domestic hot water. So why don't we get right into it?
I couldn't agree more. What I want to talk about first is I want to talk about when and where exactly is hot water used. Now, what I mean by this exactly is I want you to think about where you should be using hot water and where it doesn't always work out the way you expect it to. For example, I'm a boy, which means I'm gross. This is just the way that it works. When we use the washroom and we wash our hands, all guys do the exact same thing. We turn on the hot water, we go all the way to hot, we wash our hands for 3 seconds in cold water, and then we walk out. Now, granted, we've opened the hot water tap, but we definitely do not wait for it. So I wanted to kind of just get a good firm line understanding of where you and I believe hot water, domestic hot water, is actually used.
Yeah, absolutely. I mean, domestic hot water is used in showering.
100%. Do my best work in there. We use it in dishwashing. Dishwashing, always hot water. So really, when it comes to proper domestic hot water, showers, dishwashing, what else have you got? I mean, for real, what else can we think that we can absolutely must use hot water for?
Clothes washing. Depending on what our source is for creating that hot water, we might think we're using hot water, but it might not be getting there till maybe half or 3/4 of the way through the cycle.
We kind of preface it like this for a reason. We do have this piece kind of coming up, but I wanted the people that are watching this to really think about where you properly use hot water inside your home. And the reason for this is because, in my experience, we use so much less than we actually think, which means that we dramatically oversize our pieces of equipment. Let's expand upon this. We've already talked about the pieces of hot water, what we use, how is it manufactured? How do we make that hot water? So what are the kind of, Adam, in your opinion, what are the big three when it comes to domestic hot water generators?
Tank type.
Yep.
Tankless. And then I guess we're just talking residentially right now. So indirect.
Absolutely. Tankless, and then your boiler and your indirect. Each one of them, they got their pros and their cons. When you kind of lay them all out and put them side by side against each other, the way I would see it is everything kind of has its place. So we have our tank type that are good for a dump load, such as flooding the ice with your Zamboni. Your tankless water heaters are right there in that world where we can do the load matching. And that makes a whole lot of sense to me in a lot of residential applications where we're literally just talking about our faucets and our showers and our laundry and dish services, which, as we just discussed, those are the big ones. And then your boiler and indirect, again, that still kind of falls under a tank type application. And the reason I kind of wanted to even broach these things was to get a good understanding of what specifically a dump load is and what are the details about why we need one over the other. Tankless, I like for when we just need the use, and our use is going to be standard fixtures. Our dump loads can be used for, are we going to be taking baths in this house, or are we going to be flooding the backyard to fill the Zamboni, stuff like that. So we're going to have those two basic pieces there. Now, when we're sizing water heaters, for anyone that's ever done it, there's a couple different ways you can do it. You can use your ASHRAE standard, which admittedly right in that standard is dated. They come right out and say that, this leads to usually dramatic oversizing. We can use manufacturer's list to size these things, or we could just do a fixture count. Do you have a preferred method?
It really depends on what we're trying to achieve, but fixture count is important. You need to understand how many GPM need to flow through. I worked on a 21,000 square foot home just north of London, Ontario. And in that palace, we basically had to split the house in half and treat it as two homes within one because there was just too much hot water required for what we needed. After we did the calculations on the fixtures, and you talk about bathtubs, those soaker tubs come anywhere from 30 gallon to 90 gallon. So they really drastically change how much domestic hot water you need. In this example, we had 6 soaker tubs, all of them 90-gallon. So the amount of hot water we needed, they had body sprayers in this, they had rain showers, they had 2 separate washing machines in different areas. So we split it in half. One half of the house needed 45 gallons per minute. The other half needed 35 gallons per minute. So we were just over 80 gallons per minute total for the whole house. And we just had to split it in 2 mechanical rooms and have one on the east side of the house and one on the west side of the house. So fixture count's important.
I completely agree. And you mentioned something there about that load and how this one was requiring 40 gallons per minute. This one was whatever it was. When we are doing sizing and we're talking about how much we're going to get out of it, when we're looking at tank type applications, you're going to have first hour delivery and then you're going to have recovery. For those that are not familiar with those two terms, first hour delivery means the tank is full of hot water, it is ready to go, and it's also got the fire ready to kind of add into that load as well. Your
Yep.
recovery means if you just turn it on and kind of let it go. So as we do size these things, we have to figure out, are we using the recovery numbers or that first hour delivery? Now, in my opinion, that there's what's called your peak demand hour rating is going to be 1 hour, 2 hours. For
Right.
example, you're not going to be filling that soaker tub consistently. Eventually, that tub's going to get full. So we can use our first hour delivery for that. I love using Zambonis for dump loads. When we're talking about flooding that ice, we don't just flood it once. We usually flood it 2 or 3 times in a row. So
Yep.
that's where something that the recovery part of that conversation will come in.
Yes. I mean, referencing back to the custom home we did, 21,000 square feet, but there was only 2 people living in the house for 80% of the year. But they're a family of 20 people during Christmas and holidays. So you have to size it based on full occupancy in the house so that if 3 people are having showers and one's having a bath and someone's doing laundry all at the same time, nobody's unhappy that they're getting a cold experience. So unfortunately, that's how we had to size this application. And that's, again, it's all dependent on the customer's wants and needs.
100% agree. And this is where the mistakes usually start to happen. When we talk about that home that you're working on, 2 people were there most of the year. If we don't ask that questions about, okay, well, does 18 other people join you for Christmas and Thanksgiving and your birthday? Then we're going to size it for 2 people. Because again, if we have 6 bathtubs, but I can only put 2 of them in at a time. These are the questions that we need to ask during the design side so we get it right during the construction side. This is where the common errors for hot water come in, is not asking enough questions about what are they actually going to use and how is that hot water going to be used. We need to know as many details about the system as we possibly can to get this thing sized right. That's how we avoid problems. We ask questions and we kind of backfill from there. So to me, that's how a proper system is sized.
Couldn't agree more.
If you had a magic wand and you could change everything in the world, do we go tanks? Do we go tankless? Or do we go indirect?
We in a perfect world for me, we have a mix of all 3.
I'm a big fan of load matching. I'm a proponent of tankless, but I also understand how the dump loads kind of fit into that one. There is a good argument for saying that there is a market for all of them based on kind of your application. And it's not to say that one is better than the other, but when you really dive into it, your tankless operation can usually operate at higher efficiencies because we're always feeding in cold water, so we always get that super low incoming temperatures. We're going to condense the heater.
Yeah.
Tanks and indirects may or may not. Now,
I'm surprised you didn't go with the boiler and the indirect, given your years experience as a hydronic guru. And you know what? Like, if I think about it, if I had to choose one,
yes,
I would choose boiler and an indirect. And we're going to get a little off the domestic hot water topic here quickly, but I'm not going to go too far. We talked last episode about how comfort is king. And it's a cliche and a lot of people say it, but do people really understand it? And what can we do off a boiler and an indirect? Well, we can do our domestic. We can also do our heating. We can also do snow melt in the driveway. But when I talk about comfort, there's no better comfort than an in-floor heating system or a radiant system.
Agreed.
And the best way that I try to analyze a customer's wants and needs before I even talk to them is what we want to achieve is If the customer's not thinking about being cold and not thinking about being warm, they're comfortable. And that's really what we can tie into the boiler and the indirect. So if I had to pick one, that would be the one I'd pick. But I definitely see a huge benefit to having tankless and tank type water heaters in the market. But
That was a fantastic answer. If our editor Kyle is watching this and needs a little clip for a promo, I would use that one. That was really, really good answer. So I'm not going to argue that. I think what you said was beautiful, and I have no interest in debating that. I think that we can both agree that there's a place for everything. But you made an excellent point with the comfort portion of it. The next kind of world of domestic hot water is how we're making it in the first place. I saw a YouTube video a little while ago, and a builder that was removing an electric water heater to put in a more efficient tankless. And I'm watching this video, and of course, the math in my head starts flowing, and I become immediately furious because I know for a fact that electric water heaters are technically more efficient. You have 99.8% of that energy going right into the water, where tankless is, I don't know, 93 or whatever it is. It doesn't matter.
yeah.
But there's a lot of misconceptions about the efficiency versus gas versus electric. And then you had, in the last couple of years, heat pump enter the domestic hot water world, which has changed the game again. We now have a gas-fired condensing water heater at that 91, 92%, the tankless at that 92%-ish, your electric at 99, and your heat pump with, you either say it two ways, either a COP of 1.3 or 300% efficient.
Yep.
I want to hear from you what you have heard with regards to the pros and cons specifically of the heat pump water heater.
It's been a mixed bag of conversations when it comes to heat pumps. And there's lots of people that think they can't keep up with the recovery rate and the demand on domestic hot water, which there's an argument for. But there's a lot of people that think that it's the way to go because it's, like you said, 300% efficient, and they're going to make up so much efficiency and operational savings on costs and stuff like that. The conversation can go one of many ways. Me personally, I see both sides of it.
Mhm.
Do I have some concerns about the recovery rate on a heat pump? Yeah, I would. Do I think it's achievable if it's done right, if it's sized properly? Again, understanding what's happening in the system. Are there soaker tubs in the house that are going to run at the same time as a shower or a laundry system? So again, in the planning stage, understanding what's going to happen. But is there a place for heat pumps in this domestic system? Absolutely there is. And then we also introduce the gas heat pumps to the market, which have better recovery rates, right? So there's lots of new technologies out there that are coming down the pipe. And there's a lot. I was looking at the new product showcase for CMPX, and there's tons of products on there. I'm pretty excited to go through it and see what's coming down the pipe.
All of these pieces, 100% agree with. One of the other cons that I've heard for heat pump tank type water heaters is the fact that it's taking heat out of the air and injecting it into the water. That's how everything works. It moves heat around. And by doing that, you are cooling the air inside the room. So people are afraid that we're going to freeze our pipes by putting a heat pump domestic hot water heater in there. All the projects that I've been on that do have tank type domestic hot water heat pumps, it may drop the temperature of the room a couple degrees, but we're definitely not freezing any pipes. That's for sure. I think that's a dramatic overstatement as to how cold that room is going to get. And in the commercial industrial world, if we're using a domestic hot water heat pump, we still do reject that cold. But these rooms that we're putting them in are usually, well, if you've ever been in a boiler room, I don't know, 140 degrees. You want to cool it off? Okie doke. That sounds fine to me. So there is a definite home for the heat pump water heater in this marketplace. They are usually a little bit larger because we do need that. We need the evaporator, we need the compressor and the condenser and all those pieces inside of that all in one. So we do get a bit larger. But if we plan it right and have the conversations first, it can definitely be a home run product in the whole thing. Nothing is wrong with any of these selections that we have. I would encourage homeowners and building owners to figure out what is going to be the best for their tenants. Are you looking after multifamily with, there's a lot of the people stay home or they have kids? Are we looking after a condo where everyone at that condo works, like a downtown Toronto where they're gone, a lot of the hours of the day? I wouldn't put a tank in there. It'd be an energy waste. But there's a lot of pieces of the conversation for domestic hot water. This is why I was so excited to talk about it. There's nothing that we can say about domestic hot water that's wrong. We can really just explore the whole opportunity and see what the whole thing looks like, and especially for domestic hot water, which to me is so fascinating because if I get it right, I will never hear about it. But if I get it wrong, I will never stop hearing. I will never stop hearing about it if you undersize domestic hot water.
That's exactly the conversation I had when we were sizing that custom home. Is, you're not going to call me 75-80% of the year, but I don't want my phone ringing on Christmas Day when you guys are trying to cook dinner and people are trying to have showers, get ready for dinner and everything else. And you're really mad because I didn't size it properly for everyone to use hot water at the same time.
The domestic hot water world, I alluded to at the beginning of this show about how boys wash their hands after the washroom. Now I know I've let the cat out of the bag, and every man on this planet is gonna be furious at me for sharing this, but there's a lot of truth to this podcast, a lot of truth right here in our hearts. Now, of course, there's a solution to this. We are smart mechanical people. We have engineers that are brilliant. We have contractors that do unbelievably good things. And we have wholesalers and representatives like yourself that sell these pieces of equipment. I want to talk about recirc lines, where we do open the tap and we actually get hot water right there when we need it. A couple pros. We are able to reduce our water usage tremendously. For those that do turn on the hot water tap and wait for it to get hot, you lose a lot of that water going down the drain, waiting for the hot water to come. A hot water line, a hot water recirc line is going to put it there at your fingertips. That's the biggest advantage to it, is that is the no water wasting. A couple of the cons that we have are going to be, they can be perceived as a little bit complex to install. And in the best application to install them, you want to do that right at your construction phase. You can run a dedicated recirc line from your furthest hot water tap back to the tank or the tankless or whatever. You can also use the crossover valve. Those have become, kind of standard in the recirc world, and the crossover loops and stuff like that. But we haven't. It doesn't seem to me, Adam, that we've really fully embraced the recirc world, which I think is a misstep on our part for what it's worth, because we could save a tremendous amount of water, and that is important for sure, but also the energy savings that we have in that. I'm really keen to get your ideas on domestic hot water recirc.
My thoughts on recirculation and having that line is imperative in my mind for a few reasons, but the one for me in my household is I have a tankless water heater. There was always a complaint from my wife that we aren't getting hot water quick enough, or even the complaint from time to time, not all the time, but sometimes, that, they get the cold water sandwich. If you don't know what the cold water sandwich is, it's when you get hot water, then you get a blast of cold, and then you get a hot water blast right after. And apparently she doesn't like that. So I said, well, I have a solution for you. We can put a recirc line in. There's also a new recirculation pump that you can use for tankless and point of use water heaters that you mount on the top of the system, and it provides the domestic hot water through the what they call recirc. That was the solution for our issue, and happy wife, happy life.
One key consideration for the engineers, the designers watching the show with regards to recirc, you want your recirc going nice and slow. You don't need that water zipping through. I have my own personal rule of thumb on residential systems. Just for what it's worth, when I say residential systems, I mean anything like a triplex and under. Other thing over top of that, say multifamily. So residential systems, I like to see that water move usually no faster than a 1 gallon per minute. Nice and slow, give you a nice decent delta T, and you have some consistent flow, and everything's going to stay hot. If you're putting a recirc line on a tankless water heater, everyone's really concerned that they think the tankless are only operated on flow. They are not. They're operating on flow and temperature. You need both. So if the water does recirc too quickly and you don't have that proper temperature drop, everything's going to be okay. It's not like your tankless is going to be firing all the time anyway. In commercial systems, again, I want that recirc line nice and slow. I don't need to zip water through for a recirc line by any means. Certain provinces have certain codes. For example, Quebec requires the recirc line to return back to the mechanic room at no colder than 135 degrees Fahrenheit. So that's only a 5-degree delta T from where it leaves at the 140 required by code. These are what I'm talking about. Nice, slow, easy pieces. Depending on what temperature you're going out at, I like to see a moderate delta T, Keep the water slow. Don't zip it through. You don't want that water coming back super quick, fast, and hot. That's not what you want.
That water needs to go slow through the recirc line for a variety of reasons. We don't want the velocity going through there too quickly. We want the pipe to be in its best condition possible. But it's going to lead right into our next topic here is scale and water quality. And specifically here in Ontario and other parts of Canada, we put a ton of chlorine in our domestic water. What are your thoughts on chlorinating our water, Matthew, and the reason we've seen it so high in some instances?
So there's a little bit of a difference between the amount of chlorination that goes into our water and our scale side. But I'm going to talk about the chlorination side first. Specifically regarding water hygiene is where the high levels of chlorine come in. Now, there is a little bug out there. We've all heard about it. It's called Legionella, and that lives in hot water systems. Just hot water systems is where it thrives. So we over chlorinate because I've seen it. I've seen the reports, the numbers coming back from tests that we've done. We over chlorinate our water in Ontario for sure. The rest of the provinces, I can't comment on, but I know that we do that a lot here. And we do that because we want that water as healthy and clean as we possibly can. The downside to what's happening is that the amount of chlorine that we're putting in is detrimental to a lot of the materials that we use and the systems themselves with this high level of chlorine. If you look at there's a page in the boiler manual. I call this page 32C. And this page will tell you the water requirements of the boiler or the water heater, whatever you're working on. And it tells you your maximum amount of chlorine allowable inside this water. And I've never once seen domestic water coming in from a city at under those chlorination levels because we try to nuke the bugs. But by nuking the bugs, we kill our material. So this is not a happy medium whatsoever.
I think back to a job, and I was called to site because there were failures happening in the system, whether it be through the piping or through the equipment. It was at a car wash, and we did a water test, and we wanted to see what's happening in the water. What can we determine the causes of these failures? And after getting the water quality sample back, it was nearly 28% chlorine. Now, to be fair, we were just down the road from the treatment station, so it was fresh water coming right from the treatment station. So the chlorine was higher than it normally would be in other parts of the region. But still, 28% was high. When we talk about our recirc line, we talk about the flow rate, we want it nice and slow for a variety of reasons because that chlorine can be detrimental to piping.
Yeah, it's an issue and it's a problem that no one kind of seems to really be addressing this one because what's happening? The water's too clean. Well, it's not just about the hygiene of the water; it's also about what we're using, and it costs us thousands or tens of thousands, depending on the system, for the material that we're breaking. Off the hygiene portion of it and into our scale side of things, they're properly known as mineral salts, and they come out of our water. We have some mineral salts that come out of solution as water is heated, some mineral salts that come out of solution as water is chilled or cooled. So we're going to have scale build up in our hot water systems and our boilers. We're also going to have scale build up inside of our chillers and our cooling systems. There is a number of schools of thoughts on what we can do about this scale level. We can demineralize the water, bring it down to a 30 or 300 parts per million, something like that, which is a nice happy medium. We can soften the water where we're replacing our calcium and magnesium ions with sodium ions. That's your water softening process. And I've also had some people, and I'm going to unpack this one a little bit, say that they prefer to fill their heating and cooling systems with RO water. And I want to make sure that everyone knows if you do this, you will see me sooner than you think because you are going to destroy your equipment. You are going to eat right through your heat exchangers with RO water. Water does not, let's start that again. Dihydrogen monoxide does not exist in nature. Proper H2O does not exist. It's a very unstable elemental compound and it will aggressively dissolve anything that it touches. So if you put dihydrogen monoxide into a system and it says, oh, is that some carbon over here from the side of your tank? Or is that some nickel on your stainless steel heat exchanger? I'll take that. And it'll dissolve it all.
I think you call that hungry water, don't you, Matthew?
I sure do call that hungry water. Absolutely. This is the part of the conversation where, again, I was so excited for because there's so much to the water quality side of it that I really am happy to unpack this one with you, Adam. And One of the last little pieces that I got here on my list, and it kind of goes back to scales. I want to talk about maintenance. I want to tell you what the maintenance is for your standard domestic hot water tank, the one that's in your basement, likely at your home right now. I want you
Yep.
to think about how often the manual says that tank needs to be flushed. Now, if you know, then you are shocked. And if you don't know, prepare to be, because it says that your tank needs to be flushed every 30 days. Who does this? No one. No one ever. It has never been done. In a best case application, you're flushing it once a year, maybe. Most people will never flush it and they'll just change their tank when it leaks. That's the way it's done. Every bit of information that we have in all of these IOMs, our installation and operations manual, will tell us how to maintain and keep peak performance. That doesn't necessarily mean that that's something that we are going to abide by, because it's tough. Maintenance can be a tricky beast for this animal. If you don't do it, your equipment's going to have a shorter lifespan. If you do it, you're going to have an increase in operational costs. It's a heck of a trade-off. And that's the interesting thing with domestic hot water and how we create it, how we treat it, and how we service it in the long-term scale.
The other point to that, Matthew, is, monitoring and checking and changing the anode. The anode performs a lot of tasks that within that system that people don't realize. So the water's looking to attack something in that system, like Matthew refers to it as it becomes hungry. So the anode is in there to ultimately act as the first point of contact for that water that's hungry. It's going to attack the anode before anything. So if you're inspecting that anode, you want to make sure that it's in good shape. There's still part of the anode left. And if there's not, it's time to put a new one in. And the industry recommends every 2 years to inspect that and replace it. Does that get done? Sometimes, not very often. But if you want to protect that tank type water heater, that's the best way, is like Matthew said, give it a flush, check the anode regularly, and if it needs to be replaced, do replace it.
We take care of the pieces, they're going to take care of us. In that flushing world, let's move over to tankless for the flushing piece of this conversation. Tankless water heaters, I get asked this question all the time: how often do I need to flush my tankless water heater? And I give this answer for pretty much every question I get asked in the industry now. It depends. Depends on how hard your water is, how much you're using your water heater, stuff like that, to see how fast scale is going to build up on that. One thing I will tell you is this: a lot of tankless manufacturers out there have put a lot of technology into anti-scale. They will tumble the water through the heat exchangers, and as opposed to just kind of standard flowing it through there, so the sediment and the scale can't stick to the outside of the copper elements very easy. We have manufacturers out there that create little clamp-on ultrasonic anti-scale devices that keep the water kind of vibrating a little bit, again, so it can't stick to the inside of things. But if your tankless does need a flush, and eventually it will, all of them will, it's going to happen. It's not as complex as people think it is. You're literally just running a cleaning solution through the tankless that is designed to see every single day, all day. That is the only part of maintenance for a tankless that I say people are a little bit afraid of, because we're not used to that flushing world. And we think it's a lot more complex than it is, but it's really simple. And the machines are designed to see this type of maintenance and service. Contractors out there are getting really good at it. You can get it flushed through with a aggressive chemical if you want, or a not so aggressive chemical, whatever works for you. But don't be afraid of flushing your tankless water heaters. I'm not saying you need to do it. In fact, the new ones, the new generations, have a pop-up code say, hey, I'm ready for a flush. We've come a long way in the tankless world, and the idea of being afraid of flushing them, that's kind of a silly one. And if you ever to actually do a flush on a proper tank, screw that. Forget about that. When you do get the opportunity, for our contractors out there and the engineering world and everybody, when you have a chance to take out your hot water tank, if you have a tank, or any hot water tank, if you get the chance to cut this thing open, do it. You will be shocked with the amount of sediment
Absolutely.
and debris that builds in the bottom. Adam, how many times have we cut open tanks and seen 12 inches of sediment in the bottom of these tanks?
So when we're doing the flush, we're not only flushing it for longevity of the water heater, we're also flushing it so that the operational costs stay low. Because for every inch of sediment that builds up in the bottom of that water heater, your water heater is working that much harder to heat the water. And your water heater becomes less efficient the more sediment that's built up inside it. So we want to make sure we get that sediment out and keep heating our water and get the most amount of heat transfer we can from that burner to the water without having to heat through a bunch of crap in the bottom.
Yeah, like a foot of sediment at the bottom. It's like mud. When you cut these things open, it's horrible, and you can't believe that you ever washed your dishes with this water. But this is the world that we live in. That sometimes when you peek behind the curtain and you look at you look at the wizard and how it's actually made, you're like, oh, that's terrifying. But this is it. This is why we talk about these things. This is why we talk about what system is going to be the best for the application. This is why we talk about water hygiene and kind of chlorine that we put in there, and how to keep it clean. And we talk about Legionella disease and all these waterborne bacteria. This is why the domestic hot water conversation to me was so important. And I'm so happy that we were able to do it as one of our first shows in this beautiful mechanical business podcast. Now, what I want to note is that this topic is important to me. I want to hear all about what topics are important to you out there as a listener. I want you to send us stuff, send us comments. We have our own email address set up that Kyle's going to monitor and never show me because I can't be trusted. And if you were to send us a message, please send us messages. We want to hear all about the things that you want to know about. We are passionate about so much in this industry. And domestic hot water is just the tip of the iceberg. Let's keep going down that rabbit hole, and you're right there with us. Let's go together. Be our guide. Show us where you want to go.
Matthew, before we sign off on this episode, it's been a great time talking to you about domestic hot water. But I guess most people are probably, if they're still listening at this point of the episode and they're watching, they're probably wondering what in the heck we're wearing.
Yes. So these are a cowbell. You're welcome.
This is cowbell.
We got a couple notes from the last show. We need more cowbell. Believe it or not, these are not new shirts. We've had these for years.
Yes, we have. Yes, we have.
And we care of each other. We like each other, and we're happy to have fun. And we want to have fun with you. So come back for more episodes. Keep joining us. Keep chiming in.
If you have an idea on what you want us to talk about or bring in an industry expert on, send us an email at mechbizstudio@mechanicalbusiness.com, and we'd love to hear from you. Take care, everybody.
Take care. So much fun. Happy to see you.
If you have an idea on what you want us to talk about or bring in an industry expert on, send us an email at mechbizstudio@mechanicalbusiness.com,